So we're gonna go straight to optical measurement. I've got some stuff I'm gonna hand out to you guys. I want you guys to work as groups today. So today's gonna be basically lab. And I will walk you through some of the stuff. I'll keep one of these, each one of these for myself. And if you need, if we're short, then we'll get them caught up. Okay.
One of each?
One of each.
Per group or
Per person, because I want you to individually turn them in, or actually I want you to individually have them. I really only need you to turn them in as a group, if you would. I have 4 parts. We are going to use the optical comparator today, and we are going to use some eye loops today. And so one of these is mine, so please don't break any of them, but especially not mine. So this is essentially, this little thing right here is essentially that same thing as what that is. Anybody ever used an optical comparator before? You? Did you guys have an optical comparator?
No, we didn't.
So, funny thing about the optical comparator is it looks like it's like some from the 30s or something, and it kind of is, but it's got a ton of technology behind it, and they are used all the time and every day. So, don't think that they're not valuable. So, you guys got it figured out? Yeah. Okay. Look.
It just stopped.
Seemed like it became something. So I'm going to give you guys, I got 4 of these I'm going to hand out, and I got 4 of these I'm going to hand out as well. And so here's what I'm looking for. You guys used these in PMI. And I've got, I've got a video, sorry. Okay, this is the part that you are going to have, and you are going to fill out the dimensions for it. You can use the eye loop, and the way it works, you have to take your glasses off before glasses, or at least I do. And it's got a small little scale on it, it's got some radiuses on there, it's got some degrees on there. I'll pass them around so you can take a look at them if you've never seen one before. So 1, 2, 3, and 4. If you would pass it around when you were done with it. Flip it the other way. Yep. So you should be able to see there's an inlay on there that shows all the dimensions. You can just lay that down on top of the paper, and you should really be able to just figure out what dimensions are. So like on a print, you can look at line type and stuff like that. You can figure out angles and holes. So I'm going to give you guys these parts. Using the optical loop, you could measure some of the sizes of the holes, the sizes of the flats, the depths of the flats. It's probably as far as you can go from that. The rest of it's going to be done on the optical comparator. I'm going to give you an optical comparator, or I'm going to walk you through the optical comparator in just a second. On this sheet, what I'm looking for is working as a group. So some of this is just information. I want you to use that eye loop to figure out what the diameter of this black circle is, what the line thickness is this way, this is length, this is thickness. Thickness of this line, and then measure the inside length and height. So length and height of the rectangle. And then some are in inches, some are in millimeters. So you're going to do a little converting on that. You're going to have, this says each team has 3 parts to measure, check as many dimensions possible using optical visual inspection tools. But you're going to have 4 groups of 3 probably is how it'll work out. And what I want is as many dimensions as you can possibly get on this, not using any kind of measuring tools, okay, other than the optical comparator and then the eye loop, okay. While the eye loops are going around, I'm going to switch over here and see if I can remember which one this is. And we're going to look at the optical comparator. So if you would, you could You can either move up over here, or I doubt you'll be able to see from where you are, but feel free to come this way. So the optical comparator has a grid overlay that goes on it, and it has all of the dimensions on there. So 25, 50,000, 75,000, 100,000, and so there's increments on there, maybe 5,000, maybe 2,000, depending on what kind of the overlay is. Sometimes you would not have an overlay on there at all, that'd be fine. Sometimes that they would be thread overlays. So it's just a sheet that comes off of it, and you replace it. So one of these overlays is a couple $100 though, so even though it looks pretty flimsy and pretty simple, like they're pretty fragile and pretty important. So the way the optical comparator works is this is one of the parts that you're gonna check. And so if you wanted to maybe check for what some of the groove widths on this part, one of the things that I do is so it moves around just like a mill table, where it moves up and down, left and right, and then in and out. And then it also has the ability to do blind holes, so you have these optical or fiber optic little dudes here that come out, and so the thing about them, they don't really work that well. So the one blind hole that you have here, I'm not really worried about it. Okay, so you can bypass doing it because it asks you for a diameter of it. If you can get that with the eye loop, great. If you can't, I don't want you to really spend a lot of time doing it here because it should reverse the shadow on it by putting light inside of it. It doesn't really do a very good job. I usually put a flashlight to it to try and get the rest of the light in there. My eyes are 150 years old too, so that might be the problem. So this one has with it this digital readout. This digital readout is pretty programmable, and so to figure out hole patterns and several different things along surfaces and shapes. So what I'll do is I want to, on this print, figure out where the datum point is. What is, you guys remember what datum is? It's a 0 point on this thing, okay? So I'm gonna figure out where 0 is on this part, and I believe it's up here, okay? Yeah, up here in this corner. So that means up here in this corner, but that's not a measurable corner, is it? There's nothing there, it's in space. So what I'm gonna do is I'm going to lower my table all the way down. There is no rapid. If I knew a joke, I'd tell it. Alright, so I'm gonna get this thing into view the best I can. So I can see that corner over there, I can see that edge there. Super fuzzy, so I'm gonna do some rotating of it and then move the table in and out, or move the part in and out until it comes into focus. See how it came into focus there? See how shiny or how crisp that line is? That's what I'm looking for. Yeah, these things. Okay, so now I'll come over here, get my line up and down here. That's my 0 line in this direction. Come over here. Run this thing up. Get my 0 line in this direction. Over here. So now I know where everything is at. And so now I can go start zeroing some things out. I hit this button that says X and Y, it says 10. X and Y. This is my Y direction. And so I can go Y. And then I can go all the way over here. I'm going to pull it back down a smidge. Should have got this one over there. Right there. And that is X or 0. So that means that is the intersection of those 2 points. Okay. So now, if I want to know where, let's just say from the end of this part, where one of my slots starts at. So I go to the center point, or the end, or the intersection here, or the front of that slot, I line it up, it is 1 inch 395 from the edge, okay? So now if I wanna just know how wide the slot is, I go X of 0. Go over here to the other side of the slot. It's 200 thousandths wide. Other way I could do that is just count out the numbers on there, so it move by 5s in there. Okay, so it moves all around. I can measure the depth of the slot. So I could go all the way down here. Slot is almost a ½ inch, 495 is what the depth of the slot is. Okay. So as long as it's in focus, a piece of equipment like this should be able to measure within about 3 to 4 thousandths. So it's pretty accurate for what we're talking about. Okay, questions? Think you know how to use it? Okay. Have a seat. I want everyone to get a chance to, well, at least one of y'all have all got to look at the optical or the eye loop. So here's what I'm gonna do, is I'm gonna go, we'll do 3 groups. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay? So look at your group, and you're like, am I the smartest? Or who is the smartest? Okay? So that's what you want to look in yours. I want all of you guys to be working on this. I have 0 expectation that you know anything in this. So feel free to ask as many questions as possible. Please work as a group. I know oftentimes in labs, one person does all the work. Do not be those people. Doesn't matter. We don't care about the thing that we're checking. We care about, are we learning how to check the things, okay? So, yes, that is group, yes. So 4, 4, and then kind of a 3. So 1, Eli has group 2, and Chance has group 3 on there. And so you have 12 minutes to finish this. I'm just kidding. You have as much time as you need. I am available to answer any questions that you might have as needed, but I will not, I just won't give you the answer. I'll show you how to do the thing, but I'm just not going to show you how to do, or I'm just not going to tell you the answer of it.
Keep getting your t-shirt.